Él es un consultor en Tucson, Arizona, y ha trabajado en el pasado en muchos estudios meteorológicos, en aspectos educativos también, y en particular en áreas de protección contra descargas eléctricas, rayos o relámpagos. Es lo mismo. También en el impacto que causan en la población. También ha trabajado en laboratorios de la NOAA en Oklahoma, Colorado, Florida y Maryland. También fue consultor para una empresa internacional que elabora mucha instrumentación científica de nombre Vaisala, la empresa. Tiene una componente de descargas eléctricas y varios años, analizando descargas eléctricas, redes de detección, relación con radar, lluvia, inundaciones y creando climatologías de este tipo de eventos meteorológicos. Han participado en varios programas de campo, Estados Unidos, el Caribe, África. Pertenece a varios comités internacionales relacionados a descargas eléctricas, tanto en Estados Unidos como en otras partes del mundo. Y tiene alrededor de 30 artículos en revistas internacionales y por ahí de 19 libros o capítulos de libro. Tiene un libro que publicó hace 2 o 3 meses y voy a hablar un poco de él. Es sobre Arizona, el libro. Tiene algunos premios de la Sociedad Americana de Meteorología y de la Asociación Nacional del Tiempo en Estados Unidos. Ron, could you please take time for our seminar? Thank you for presenting this good seminar for us.
All right, thank you. Should I turn off my camera?
I think so.
Yeah, I think it's probably better bandwidth. Well, thank you for coming.
The broadcast of Facebook Live has stopped.
I'm going to start it up again.
Sorry, I have a little bit problem. Can you wait 5 minutes, Mr. Holle, please?
Okay.
Thank you.
This meeting is being broadcast on Facebook Live.
It's okay. Thank you, Mr. Holle.
Okay, ready to go again?
Yes.
All right. Well, thank you for having me. I'm very much interested in the meteorology of lightning and thunderstorms in Mexico. I've been studying it for quite a long time. First of all, I know you have a storm coming in, Hillary, in the next few days, so I hope things aren't too bad in your area. But the National Hurricane Center track has it coming right over you. I've worked in Miami for 13 years and was closely affiliated with the National Hurricane Center. I didn't work there, so I know a good deal about how the forecasts are made. So this is a very interesting situation. So I'm a meteorologist. I've flown into hurricanes. I've chased tornadoes. I've flown into storms over Africa and Florida and so on. So I've been doing convection and thunderstorms for my whole career, and lightning is just one of the things that come from thunderstorms. There's also hail and dust and wind and heavy rain. So these affiliations here I'll be talking about through the talk. So I have 3 topics today. We'll see how far it goes. First one is lightning in the North American Monsoon. Second one is a new Arizona lightning book that we've just recently published. The third one is about lightning casualties and safety. So let's talk about lightning in the North American Monsoon. Dr. Farfan knew this particular publication and asked me to review it. This was done in 2015 with the Global Lightning Data Set GLD 360 data, and with Dr. Martin Murphy, who was a University of Arizona graduate and is with Vaisala. So here's a global map of lightning from the Global Lightning Data Set GLD 360, a network that's owned and operated by Vaisala. And this is a map that has an average of 2.2 billion lightning detections every year. As you see, there are a number of maxima around the world. The biggest one is probably in the Eastern Democratic Republic of the Congo. There's a very strong maximum in northwestern Colombia. There are also the third largest one is in somewhere around here in Borneo, I believe it is. But you notice that the northwestern Mexico area has a high amount of lightning also. So here is the newest map that I could find from the GLD 360. This was in the annual report of lightning that was issued at the end of 2022. And this is the Mexico map that was produced. So you see there were 41,599,000 events detected over Mexico. And many or most of these are cloud to ground. You see the maximum is probably down here, but also this maximum right up here through the Sierra Madres is very important. So I went to the website. First of all, there is this, we'll talk about that in a minute. This is an annual average that is smoothed a little bit, and we can see these maxima even better. And notice that the maxima also extend to some extent over the Gulf of California, the Sea of Cortez. There is an interactive map at interactive-lightning.map.vaisala.com where you can do all these different combinations. And I zoomed in a little bit more here for the northwestern part of Mexico. And I live right up here, just about right there. So that the monsoon from Mexico extends up to us and sort of ends a little bit north of us. Another thing that can be done in this interactive lightning map is to zoom in, and you can see the densities over each state of Mexico. And here's the scale down here. And that's the northern part. And then, here's the southern part. And as you zoom over, you can see these values pop up. So this is a very interesting map to look at. I encourage you to do this. You can go anywhere in the world, any country in the world, and as you zoom in, the counties or states or districts are shown in more and more detail and have the values on them. So it's a really fun map. It's quite new. So let's talk about the monsoon in North America. Here's the elevation, and of course a lot of this is due. The monsoon is due to the Sierra Madres, and there is an extension of the mountain ranges up into the Tucson area where I live, and there's a separate mountain range up here called the White Mountains and the Mogollon Rim. Now, mesoscale convective systems are very important. I grabbed this image last night around sunset, and you see that the largest organized convection in North America is over northwestern Mexico, and some of this made it into the southern Arizona last night. This is not uncommon. These are very large systems. They have a lot of lightning. They have a lot of rain. So these are really important systems during the period when they exist. And I don't remember exactly when this is. This was a few years ago. Tucson, this is Arizona right here, and I live right around here. This was a large system just before sunset that was caught on the visible satellite image. Well, this is a really large area, And as I recall, there was a lot of lightning in the storm. And for that reason, Dr. Farfan has done the right thing. He did characteristics of mesoscale convective systems over northwestern Mexico, Gulf of California, and Baja California Peninsula. It's a very good reason to study these systems because they are lightning producers, they're rainfall producers, and they're very large. So in our study with Dr. Murphy, we went through and did monthly maps of lightning density. And here's the sequence. This was quite early in the network. It's improved since then, but the patterns have not changed. So in April, you see there's really no sign of the monsoon. In May, already have it to the south. In June, it extends up not quite to Arizona. We don't expect the monsoon until around the 1st of July. And then look at July. I mean, the change from June to July is amazing. And it ramps up very quickly. And we here in Arizona are hoping that some of this will reach up to us. This year it's been kind of weak, but I think it's still going to come. August is at its peak. In September it dies back down again. So this is one of the most concentrated phenomena in terms of lightning frequency that I know of in the world. It's so short and so intense that it's quite amazing. So I blew up the panels here again, April, May, June, July, August, September. Now the time of day is also interesting. This is all for that whole data period, that whole 6-month period. The time here is in UTC. So for Mountain Standard Time, where you're in and I am in, subtract 7. So 00 is 5 p.m., right? 24 minus 7. Yeah, 5 p.m. So it's pretty much at its maximum. Then it gradually dies after sunset, goes down to the minimum at sunrise, which is right around through here. And then the storms begin again in late morning and then quickly develop. So it's a very distinct diurnal pattern as well as a monthly pattern. This has been shown by satellite data, but I think the lightning data have better resolution in time and space, and they're much easier to handle than satellite data. All right. So this is the last part of the study that I did with Dr. Murphy was to look at the lightning pattern at Mazatlan, Cabo San Lucas, and a halfway point called H. And so we have the diurnal cycle of lightning in those 3 places. So Mazatlan has a strong lightning maximum during the night. Let's see here, this is about 1 to 2 in the morning. These storms, mesoscale convective systems, come off the land and move west, and typically. And halfway across, they reach there before sunrise, between midnight and sunrise. And halfway point doesn't really have too much because it's over the ocean, so it didn't show up much. By the way, I was in Cabo San Lucas back in May on vacation, and we stayed at Pueblo Bonita, so we had a good view out to the last rock on the southern tip of Baja. One of the things that can be done with lightning data, because it's so easy to handle, this is a map, a graph of the last 30 years in Arizona. The National Weather Service in Tucson has developed a running average of lightning over the state, and also I'll show you Tucson. You can see that the variability from year to year is fairly large. We don't see trends. The variability is so large, you can't see trends. 2020 was terrible for us here in terms of rainfall. We had a lot of fires and almost no rainfall. and almost no lightning. It was just unprecedented. This year is not doing too well so far for the state. But this is online, and this was updated. This is from last night. If you go to the Tucson area, they have another depiction here. These are all the years since 1990, and here's this year. Again, we're below average. This is the mean of all the past years, and this is this year. So we had a burst of lightning activity around the first of the month, and then it's been kind of weak, but I hope it will pick up over the weekend. Okay, so that's the monsoon as I see it. So, because of that and some other things that have occurred in Arizona, a student that just graduated, she and I wrote a book about lightning in Arizona. Only lightning and only Arizona. And I think this is the only book in the world that studies such a small area in such detail. I wish I took this picture. It was taken by Greg McGowan, who I know here in town. It has a rainbow, it has lightning, it has a swirl cactus, it's at sunset, and it has a mountain. So there are only 2 or 3 pictures like this, and his picture we chose to put on the cover. So it was fun looking for that. So my co-author is Daila Zhang, who is a PhD graduate in lightning studies at the University of Arizona about 5 years ago. She's now at the University of Maryland. At this point, she is in China, went to visit her family, and is waiting for a visa to come back. So this was in our backyard. I had this poster made that we're doing some book shows. So that's Daila and that's me. So the first thing we did in 2017 was to come up with this little booklet about lightning with a lot of questions. And this was a lot of fun to put together. She likes to teach, and I was doing a lot of lightning education. And so we came up with this booklet. There is a version in Spanish at this particular website. There's also in Chinese if you're interested. Anyway, so we did this, and we said it was harder to write a short version of an answer to these questions than to write a long version. And I said, Daila, we could write a book about this. And she said, okay, and we did. So some of the questions that we have in the booklet and also in the book are: is it safe to use a mobile phone during a thunderstorm? Yes, if you're in a lightning safe place. Do rubber tires save you from a strike to the car? No. Does metal attract lightning? No. Are tents safe during a thunderstorm? No. Is it safe to stand under a tree during a thunderstorm? Never. Can rubber-soled shoes save you from lightning? No. Are passengers safe if lightning hits a plane? Yes. So I'll just briefly go through the chapters. I'm not trying to sell the book. I don't get anything out of it. But anyway, we have a very full description of how lightning occurs and why this particular picture that I took here in Arizona represents a lot of features. So that's the basics of lightning. The next one is a chapter that Arizonans really are interested in lightning. The diagram on the right is by a editorial cartoonist. He's retired, but he had a cartoon like this in the paper 5 days a week. And he often talked about thunderstorms because he just loved thunderstorms and lightning. So he allowed us to use one of these pictures. Now, the more interesting one is this one on the left. At the Grand Canyon National Park, there is a place called the Indian Watchtower. Some of you may have been there. And this is drawn on the wall by a Zuni tribe Native American about 50 years ago. And this is a thunderstorm with rain, with lightning coming out of it. Here's thunderstorm with one lightning coming out for some reason. Here's another one with rain. Here's another one here. Here's one in here. And down here, these people are standing there. There's rain, but there's no lightning. And this is the Thunderbird, which is a typical representation of lightning. So there's a lot of historical interest in lightning, and pretty much all over the world, but this is a really attractive depiction of it. So anyway, that chapter is about these sorts of topics. The third chapter is about what I say is Arizona is the lightning photography capital of the U.S. Not the lighting capital frequency, but lightning photography. So these are some famous pictures. Hip Peak is near Tucson. This is up at Grand Canyon. This is down near the Mexican border in Rio Rico. And this is up in northeastern Arizona. And we were able to find that there were some men, two brothers at Grand Canyon National Park in the early 1910s that were taking photographs of the Grand Canyon on glass plates. And this one, they had a number of them with lightning, and this was the best one. So anyway, this was a fun chapter to put together because it's a really big topic here. Chapter 4 is when and where and how much lightning occurs in Arizona. And as we saw before, there's a lot of lightning down on the Mexican border. Then the rim up here, which is not part of the Sierra Madre complex. And the lightning flashes over Arizona. 89.8% of the lightning in Arizona is during July, August, and September. I mean, that is really, really concentrated. So in Chapter 5, we went through deaths, injuries, and damages. Dyla is originally from China. She had a good friend, a meteorologist who also does cartoons, and she drew this for us with a coral cactus in it. And just this is a part of the long series of studies that I'm doing. The rate of deaths per million people in Arizona has decreased by a factor of 75 from the first data we found in 1926 down to now. And there's a whole story about that. The Chapter 6 is what really made us want to write this book, and that was that Vaisala and its earlier companies, the lightning detection technology was invented at the University of Arizona. It was invented on the 5th floor of the building on the south side of campus by several people. And so this was one of the early antennas in Alaska. This is what they look like now. And until about 2 years ago, there was a network control center in an office by the airport here in Tucson, and I had an office just around the corner from here, and I was able to go over and look at U.S. and global maps of lightning for the last 24 hours anytime I wanted to. So that is now moved to the Vaisala office in Boulder, Colorado. And the last chapter is lightning research that led to the National Lightning Detection Network, and these are the people that were responsible for it. Dr. Phil Kreider is probably the single most important person in this area, and Bert Pfeiffer and Garnagle are electronics wizards. Richard Orville, you may know him. He was a meteorologist here in Tucson at the university and helped develop it. And Dr. Ken Cummins has made immense contributions to the network. And there was a long list of master's and PhD graduate students in lightning studies here. And Dyla Zhang is the last one. So let's talk about lightning safety. Here's a picture of lightning from Cape Town. So notice that the lightning is coming down in all these branches. These are not successful. That's not successful. And then one of them does make it to ground. This is typical of a cloud to ground lightning flash. And here is a picture taken from Mount San Salvatore in Lugano, Switzerland, 1967. I actually was able to visit there after a conference a few years ago and saw some of the equipment that Dr. Binns had up there. Anyway, it's still there. They have a little museum of all things about lightning. So these are downward leaders. We're looking at a storm from a few hundred meters aloft. And you can see this branching going on, and then finally one of these is successful in connecting with the ground. So, summarizing a lot of physics and meteorology in a short slide here is that all lightning originates with temperatures that are colder than freezing, 15 to minus 5 Fahrenheit or minus 5 to minus 15 Celsius. And they originate in an updraft. And in this updraft here, in the minus 5 to minus 15 Celsius range, is a mixture of grauple, ice crystals, and supercold liquid water. And that combination, not everybody agrees exactly how this happens, but those seem to be the necessary things. And so the charge that is way down below is being brought up quickly to a higher altitude and creates an imbalance, and something has to happen, and the lightning begins. There are whole books written about this process. So I published a study in 2016 summarizing lightning fatalities from publications, not from anything else, but just from publications. And Mexico came in with the 6th largest number of lightning deaths. However, this list is very incomplete because many countries don't report it. But the source of the Mexico data is this 2014 paper in Weather, Climate, and Society. And here is the summary of all the multiple year papers that have lightning fatalities reported in them. And it comes out to 491 fatalities per year. However, if you look at the map of where the data are coming from, we have the data from the more developed countries, and we have very little data from Africa and Southeast Asia, where I know there's a lot of lightning deaths. We do have a few studies in Africa, and those are the highest ones. I just did a seminar yesterday with people in Uganda, Kenya, and Tanzania, because they're finally becoming aware of just how big a threat it is there. So the last part of the talk here is what's safety. So here's another picture of lightning coming down and striking a tree. You see the unsuccessful downward leaders. Finally, it connects with the tree. There are most likely an upward leader here. Here's an upward leader coming up. You look very carefully. There's a tower or an antenna over here. There's an upward leader coming up here, but the lightning decided not to connect with it. So these upward leaders are quite common, and they're saying, hit me. But they don't always do it that way. Lightning is not a very well-behaved phenomenon. Here's, as I said here, preferred strike points are tall, isolated, and pointed. And here's tall and isolated, maybe not pointed, and it missed them entirely. That's the way lightning behaves sometimes. So we have flash densities by county in the U.S. We have them by country. This annual report that we put out back in January is a good summary. In the U.S., we have a National Lightning Safety Council that has a lot of information about U.S. lightning deaths and injuries, and we also have a lot of resources in Spanish. And one of our members maintains this list. This was updated as of last week. We've only had 9 deaths in the United States, which is very, very low. But John Jensenius does this, and he documents the age and the day of the week and all the other things. As soon as these are verified, this is updated. So let's talk about lightning injury and death mechanisms. How does this happen? These are very general ideas, but we think that ground current is probably the most important source of lightning tests in trees. Side flash, where it comes from a pole or a tree sideways. Contact, where someone is in contact with a wire or a plumbing or something like that. Direct strike almost never happens. So what do you think of when you think of lightning deaths and injuries? You think of it coming down from above and hitting you in the head. Hardly ever happens. So you need to take into account these other things. These upper leaders, we think maybe even more important than this. So anyway, so it's not a simple situation. So there's two reliably safe places inside a large, substantial, frequently occupied building. I'll show you examples. Or inside of a fully enclosed metal top vehicle. So here are some myths that we had in our booklets. Lightning is attracted to metal? No. Why is that thought to be the case? Because metal is tall and isolated and pointed. But it wasn't the metal. It could be anything else. Trees are not metal, and the trees are hit all the time. Direct strike is the most common? No. You can do something outside to make yourself safe? No. If it's not raining, I'm safe? No. Here in Arizona, and certainly where you are, you have thunderstorms sometimes where there's rain but no lightning. There's lightning but no rain. And that keeping dry is not the same as being safe from lightning. And rubber tires provide protection? No, we'll talk about that in a minute. So again, you can be certainly safe inside of a large substantial building or a vehicle. It doesn't matter what you're wearing or carrying, where or how you stand, or what you stand on, in fact, anywhere outside. In this talk I did yesterday with the people in Africa, I spent part of the lecture talking about why their idea is wrong. Their idea is that wearing red attracts lightning. This apparently everyone in the continent believes that's the case. I don't know where it came from. So I am working with the ACLE Net, African Centers for Lightning and Electromagnetics Network. The schools there are very, very poorly built. They are mud brick. They have no wiring and no plumbing. They have no electricity. They have no toilets inside. So putting lightning rods on top, Franklin rod is a good word for it, is done. We have a staff member from ACLE Net doing the down conductor from the rod down the side of the building, and then it goes into the ground. In this case, it's rock, and so they dug a trench around it. You can see it here. In other situations, you can put the down conductor directly into a rod that you pound into the ground. So this is typical installation. There's been a lot of schools with traumatic experiences. Goyo in 2018. This is the inside of the school. Looks like it may be a dirt floor. I'm not sure. And these are the teachers' houses, which unfortunately have grass thatch for the roof, which is not safe. So you can't put a rod on there because lightning will instantly set it on fire. So we put up masts at intervals between the schools, between the houses, which are determined. These intervals are determined by international standards. This is a very, very mature lightning protection standard discipline. And then I wasn't there, but our director, Dr. Marianne Cooper, was there. And when they were installing these masts, the faculty, students, and the parents of children that were killed and injured were there. So again, these are the two safe places. And I think I've already did that one. So what's a safe vehicle? This looks just like my 2012 Toyota Camry. That's safe. School bus in the U.S. looks like this. It's a little small truck. So it's fully enclosed, metal top, and it surrounds people with a Faraday cage type of effect that could provide a safe path for lightning to fall to the ground. And let's say this truck is hit by lightning, it will follow around the metal parts of the vehicle and then arc over to the ground. And what happens when that happens? It goes through the tires, and tires are blown. The tires had nothing to do with being protected. That was a result of the lightning going through the vehicle. Unsafe vehicles are golf carts, ATVs, motorcycles and scooters, bicycles, convertibles, animal-drawn carts. I saw these types of things in India. A cloth top, like a convertible. I was at the Vietnam Meteorological Service in 2019, and this is exactly how the streets look. I have never seen so many scooters in my life. There were thousands of them all the time, everywhere. And they're not safe from lightning. A safe structure is one like this, where people live or work. If they follow building codes, they have grounded wiring and plumbing and metal, perhaps inside the walls of the building, like at this hospital. And again, there's a Faraday cage-like effect to provide a safe path for lighting to follow the ground. And when the building is built according to building codes in the U.S., there is a grounding rod that is attached to the wire, and there's a grounding rod attached to the plumbing, which takes a strike to the house into the ground. Certainly does damage along the way, and you don't want to be touching those paths, but it is safe inside those structures. Unsafe structure. Here is one. This was a Vizsla picnic at a park in Tucson some years ago, and one of the Vizsla employees had this sign put up on the inside. It says, "Warning, this structure is unsafe for use during lightning storms. Seek suitable shelter elsewhere." It didn't quite complete the story. It should say, "Go to your vehicles." That would be the best answer, because there are no other safe buildings around here. And unsafe structures are, that's one I found on the internet here. This one is from Asia. These from Africa. This one, I was at a conference in South Africa last year, and on the way out of Cape Town, these places are called informal settlements, where very large numbers of people live in very poor housing with no wiring and plumbing. So those are very unsafe. And some more lightning safety myths. Lightning never strikes the same place twice. This seems to be a universal phrase that is false. Lightning struck the metal. No. Cows and horses are more vulnerable to lightning than people. Yes. The reason is that their legs are further apart. And so when there is ground current and the lightning spreads out across the ground, there's a different charge at the front compared to the back feet more often. And so the current goes up through the middle of the body to the heart and stops the heart. So again, here's the global lightning map. This is a 5-year map, a little bit different color depiction, but you can just see that this northwestern Mexico monsoon is significant. And Dr. Farfan has done exactly what I'd like to see. He's combined reported deaths with lightning density and come up with an exposure to lightning. And this is a very, very good way to find out where the lightning exposure is, and also combining it with the population density. I've done a few studies like this in other parts of the country, of the world, and sometimes it works and sometimes it doesn't work. But this is a very valuable one, and I understand this study will be expanded. And lastly, just want to say that again, I'm active with the African Centers, and as I said, they think that wearing red attracts lightning. They also think that people killed or injured by lightning have done something bad, and that people can call lightning upon their enemy. These are really serious problems. People are being killed because someone in their next city or next village has been killed, and they said that those people over there in the other village did this, and they came over and killed them. So these are serious problems. And for the African people, some of whom don't read, we've come up with this sign for non-readers. We're posting these in some of the schools. And lastly, there's 2 other books on lightning. Dr. Marianne Cooper and I wrote this book 5 years ago, and it has a lot of the topics that I've covered here briefly. It's available online through the ACLE.net website. And this is another one if someone's really interested in more detail about protection. There's an excellent book that just came out of about 8 months ago. That one is not available online yet, but this one is. And that's the end. And I've talked too much, and I need to hear what you have to say. Oh, by the way, this is my license plate on my car. Fulgur. Fulgur means lightning in Latin. So I probably have the only license plate in the world with Fulgur on it. So that's me. All right.
Thank you, Ron. Do we have questions from the audience?
Yes, Luis, I have a question for Ronald.
Yes.
Okay, Ronald, thank you very much for your very interesting talk. I have a very basic questions.
Mhm.
Could you explain in more detail the origin of the lighting? For example, where the electric charge come from and the light? And another question that I have is that what is going to happen to us with Hillary? We are going to have lighting here?
Let's talk about that first. I was thinking about that this morning. I did some studies and published a few conference papers some years ago. The lightning is not in the eye wall very much. Sometimes there can be some lightning in the eye wall. The lightning is typically in the outer rain bands because it's very convective and because there's more vertical motion there. So you could see some long lines of lightning in the rain bands. But the reason is that the eye wall, the winds are traveling horizontally so fast that they don't tilt upwards to start the charge initiation. So that's what we think is going on anyway. So let's talk a little bit more about how lightning starts. This is not my expertise too much, but what I understand is that there's a charge, a standard charge distribution lower down in the atmosphere, which is different than what it is in the higher atmosphere. And when you have an updraft that goes up quickly, up to this magic layer of -5 to -15, that updraft carries charge particles from down below up into that layer, and that combination is electrically totally unstable, and lightning has to happen. That's the short version of it. People have said it has to be hail of a certain size, but it doesn't seem to always be the case. They said you have to have supercooled liquid water of a certain amount. It doesn't always seem to be the case. So there seems to be multiple ways that it happens. There was a paper in the last couple of years, I don't remember who wrote it, that they think that they detected with a specialized network the exact particles, the exact place and exact time when the first static charge began in that -5 to -15 layer. And it was in the area of this mixture of water, super cold water, hail, and ice crystals. So it verified that. This is a really tough problem because tracking all these particles is a difficult problem. We just don't have a really clear way of doing that. dual polarization radar gives quite a bit of information on this, and there's also a network of lightning detectors called a lightning mapping array, which is on the scale of 25 kilometers rather than the US network, which is thousands of kilometers. So if you have a dual polarization radar and a lightning mapping array in the same place, these are starting to be looked at in detail, and I think the ideas in general are being agreed upon, but the details are still pretty complicated.
Thank you, Ron. And how about the Hillary effect on us? We are going to have lightning here at Ensenada, Tijuana, San Diego?
I think if you look out at night and look at these rain bands, there may be two different areas. One of them is that offshore, if you look out at night, you may see these long rain bands, and there could well be lightning in them. This is a really vigorous storm. And then over the mountains to the east of you, the updraft should be quite strong, and I would expect lightning in those in the afternoon and evening. Yeah. But you may have so much cloud where you are near the center of the storm that you may not be able to see those areas too well. I don't know.
Okay, thank you very much, Ronald.
Yeah.
Thank you very much.
Do we have more questions?
Yeah. Can I make one?
Sure.
Yes.
Thanks. Thank you, Mr. Holle. I'd like to ask, what do these sensors measure? The electromagnetic field associated to the lightning strike, or how can they measure the lightning strike from cloud to ground?
I was around the people that developed this for quite a long time. The very lowest part of the channel of a cloud to ground flash, there's one in the background of my picture here. The lowest 50 meters are absolutely vertical for whatever reason. Nobody knows why. Anyway, the lowest part is vertical, and that 50-meter channel is like a radio broadcast tower. So it is emitting energy in all different wavelengths. And so the antennas are tuned to the best wavelength for detecting lightning over long range. Some of it is emitted, but it can only be picked up 10 kilometers away. But some of it can be detected 6,000 kilometers away if you know what you're doing. So the GLD 360 network is actually detecting the electromagnetic signal bouncing off of the ionosphere. And that is a very complicated thing. Dr. Ryan Saeed is at Faisal and developed this for his PhD at Stanford. And so that signal from that lowest part of the channel is distributed in all sorts of different frequencies, and depending on what range you want to pick up, you tune your antenna to that particular range.
Thank you. One last question,
Sure.
please. The lightning detection system can work inside the city, or has to be located in the outskirts or somewhere where far from the cities?
The Faisal sensors are typically placed in very quiet locations, such as small airports. They need to be electromagnetically quiet, and so there are places that, small airports tend to have a fence for safety, they have power, and they have security, and they also have a lot of land around the runways that is not being used for anything. And so that's where I think about half of the sensors in the U.S. network are placed in that location. So you don't want a lot of transmission going on from power lines or anything else around it. So, 500 meters around or 1,000 meters around the antenna is good. They just have to find a place like that.
Thank you. Thank you very much.
Would you like to say a few words about how the number of deaths in the U.S. or in other places has changed in the last few decades? How was 100 years ago?
Yeah, the figure I showed from Arizona, I think is quite typical of the U.S. Back 100 years ago, the number of deaths was very large. I was looking at some data a few days ago, and there were 500 people killed every year in the United States for decades. And now we have 9, and we think we may hit the record low. So in the United States, Canada, Australia, Western Europe, Japan, the rate has gone down drastically. So that's due to a number of factors. I think one of them is that the buildings, people spend time in safe, well-constructed buildings. People have vehicles. Farming has been mechanized, and so there are not people out on tractors all the time. The tractors are enclosed, and so they're safe. And we have a lot of information about lightning, a lot of education, and medical care. And those are all applying in those countries. In the developing countries, like those countries I talked to yesterday in Africa, the buildings are not safe. You saw how the school was built. The houses are not safe. They're thatched roof. None of the office buildings are safe because they don't have lightning protection on them. They don't have plumbing. They don't have wiring in most buildings. Particularly in India, for example, a huge portion of the population works outside in manual, labor-intensive agriculture. And so it's just a huge number of people. The largest number of deaths that we know about in the world is in India, which is 2,500 a year. And most of them are in agriculture. So the number of deaths there is not going down at all. It's probably going up. But the one problem we have with the understanding that situation is that the reporting is highly variable. In India, we seem to have pretty good press coverage, so there's good internet connections. So we hear about the cases. But in those African countries that were in white in the figure that I showed, there is almost no media whatsoever. People don't have electricity. People certainly don't have computers. So we don't know what the numbers are out there, but they probably have not changed in the last 100 years. They're probably going up because there's more people.
Luis, this is Enrique.
Yeah.
I have a question
Sí.
for Ronald. We children around the world learn about Ben Franklin experiments.
Mm-hmm.
And I just learned some years ago that actually he never did that experiment.
I don't think that's an opinion of somebody that I don't think is true.
Oh, you think he actually made the experiment?
Oh yeah. Somebody's just trying to make a story.
Okay, thank you.
But let's talk about him for a minute. He did that experiment. There were other people around the world doing it at the same time, but they didn't do it very well. And actually, one person in France was killed doing that experiment. Because his invention of the lightning rod was so important that he was awarded honorary doctorates in the United States, France, and England, and there is a number of historical scholars who have said that his invention of the lightning rod was what gave the United States credibility in the global politics that gave us support to have the revolution. They said he was the most important person in this whole process, which is an interesting book. There's a whole book on this by I can't think of his name right now. I read it and said, well, that's interesting. But yeah, he did that experiment. Somebody's just trying to make waves, make trouble.
Yeah, the story goes like he said this can be done, and some people did it and they got killed.
Yeah,
but he never actually made. Okay, but thank you.
Yeah, Dr. Phil Kreider at the University of Arizona, I showed a picture of him before, is probably one of the 3 leading Franklin experts in the world right now, and he's given lots of lectures about what happened. So I believe him.
Okay, thank you.
Sure.
¿Más preguntas o comentarios?
Please, can I make a question, please?
Yes.
Yeah, Doctor, thank you very much for your very interesting talk. I was wondering if you know the reason. At the beginning of your talk, you showed a time series of lightning strikes in Arizona, and the 2020 year was really very low level. You know, like from a climate variability perspective, what the reason could be for such a weak year?
Yeah, we're having somewhat the same thing this year. There was a high pressure area aloft right over Arizona that would not move. And we had the storms were all around us. They were south of us in Mexico. They were east in New Mexico. They were to the north in Colorado and Utah. They were to the west in California. And it just looked like they wouldn't enter the state of Arizona. So the storms were all around. It just happened not to be over us. It was very, very frustrating. We had a huge forest fire start right here near Tucson that burned virtually the entire mountain near our house. So it was bad. This year we're having somewhat the same thing, but not quite as extreme. But that year was, and the rainfall was also amazingly lower than nothing had ever been measured like that before. So, but that high just was stuck over us, and we couldn't get rid of it.
I see. Thank you.
Yeah.
So if you have that high pressure somewhere else, do you get more thunderstorms in Arizona, or is it not the only reason why?
Yeah, if the high is to the east, which is is happening now, we have southerly flow coming up over us, and so it brings up the moisture from Mexico, and that's what we want. But instead of the high being east of us over New Mexico or Colorado, it was right on top of us. So it's a pretty specific pattern that happens here.
I have seen some lightning off Southern California in the winter. Is that because some strong cell systems across the area, or?
Yeah, you saw the figure for Arizona. 90% of the lightning is in the monsoon. The other 10% is December, January, and February, and those are synoptic scale systems that have vertical motion up in this -5 to -15 Celsius level. So those are more synoptic scale Rossby type waves and so on. And they tend to have lower flash rates, and they're not concentrated over the mountains. They have nothing to do with topography. It's strictly a moving system, perhaps a cold low aloft. That's often the most important thing, is to have a really cold temperature aloft.
We noticed a case in January 2 years ago. Baja California has an island in the Pacific with name Guadalupe. Isla Guadalupe. It's about 300 kilometers west of the Baja California coast. They had a strong frontal system one day, They have lightning in the island and some fire too.
Ah, yeah, yeah.
And we were able to see lightning from the satellite, the geostationary satellite mapper.
What you need to do is have enough draft with some moisture going through that -5 to -15 Celsius layer. And any way that happens is important. It can be a small updraft over a mountain, or it can be a broad area, such as along a cold front or under an upper low.
Good. More questions or comments or?
If someone wants to contact me, Luis, they can go ahead and ask me more questions or want some references or something like that. I'd be glad to do that.
Thank you for the seminar, Ron.
I just wanted to make a comment, brief comment, if I can.
Yes.
In Spanish, we have the word fulgor, but it translates better like glint. But it's an adjective in Spanish, fulgor. Just a comment.
Yeah.
Thanks for the seminar. Very interesting.
Well, I worked with Dr. Raul Lopez, who was from Puerto Rico for many years in Boulder and Miami. And he was bilingual, and he was constantly confused about whether he should say it's relámpago or rayo. And he decided that rayo was too strong a word, and he liked relámpago more. So that's what I've tended to use. So, yes, so rayo sounds like somebody's attacking somebody.
Yeah, rayo has other meanings also. Relámpago, it's more specific. I think I think so. Relámpago is closer to lightning.
More unique. Yeah.
Yes. Yeah. More specific.
Yeah.
Thank you. Very nice.
Well, all right. Thank you for coming.
Have a good weekend.
Thank you, Ronald.
Well, I wish all of you the best in this storm. I'm concerned about the rainfall. This could be quite a serious rain event. So be careful.
Thank you. Thank you very much.
We'll follow the official forecast from the Hurricane Center and the Mexican Weather Service.
Yeah.
Yeah.
Goodbye.
Bye.
Okay. Thank you, Elena.
Bye.
Bye. Thank you.
Bye. Bye.
Goodbye.
Bye.
Luis, ¿te puedes quedar un ratito? Luis.
Sí.
Oye, si nos puedes dar un update. Lo que más que la lluvia nos preocupa el viento. ¿Tú cómo la ves aquí para la región de Ensenada? Los vientos máximos, las rachas, para el lunes.
Yo creo que si no se debilita Hillary cuando pudiera pasar por Guerrero Negro, por ahí, sigue, pueden tener como periodos de viento fuerte o digamos los remanentes, ¿no? El Centro Nacional de Huracanes cada 6 horas hace un pronóstico probabilístico de viento para ciudades, para varios puntos, depende de dónde ande el huracán, ¿no? Y en la mañana tenía, ahorita lo busco, pero tenía como más de 50% de probabilidad que en Ensenada el domingo hubiera vientos de más de 50 o 60 kilómetros por hora, que es más o menos, ¿no?
Sí.
Y como 20% que fuera más de 90 kilómetros por hora. Esto lo actualizan cada 6 horas ellos. Toman muchas fuentes de información, ¿no? Todos sus pronósticos, del tamaño de la tormenta, la intensidad, varios factores así. Al rato a las 2, en 1 hora y media, va a salir el siguiente. Si quieres lo reviso y lo comparto contigo o con quien
te interesa. Si quieres aquí con el departamento.
Bueno, y la otra cosa más o menos buena, un poco, es que hay un avión cazahuracanes ahorita haciendo mediciones, allá donde está la tormenta ahora, y por la isla Socorro. Va a haber otro en la noche, mañana hay 2, y aunque no va a cambiar la estructura ni la intensidad, sí es una manera más directa de estimar cómo está la interior, la tormenta comparada con puro satélite, ¿no? nada más. Pues va a ayudar un poco y probablemente mejore de alguna forma los pronósticos que se utilizan, los numéricos para estimar la trayectoria y la intensidad, ¿no? Eso ya lo maneja el Centro Nacional de Huracanes y lo integra, ¿no? En tiempo real. Entonces, pues, bueno, eso ayuda un poquito más para saber qué va a pasar, ¿no? Mejorar los pronósticos de aquí a... ¿Cuántos días faltan? 2, ¿no?
Dos,
Para que
sí,
ande
para
por allá.
sábado. Sí, sábado, domingo.
Hay un comentario en la mañana del Centro Nacional de Huracanes que dijeron que esta es la primera vez que emiten una alerta de huracán para el sur de California.
En varias décadas.
Bueno, creo que la cosa es como sigue. El Centro Nacional de Huracanes está a cargo de la región del Pacífico, además del Atlántico, del Pacífico desde 1988. Entonces, del 88-89 para acá lo ha hecho el Centro Nacional de Huracanes, como lo hace ahora. Pero antes lo hacía otra oficina, no ellos, lo hacía un lugar de la NOAA, el Servicio Meteorológico en California, por ahí por San Francisco. Entonces yo creo que por eso un poquito se oye que todavía no estaban ellos, no están seguros que se sientes. De cualquier manera no es común, ¿no? Que esto pase. Y en San Diego también están el Servicio Meteorológico haciendo varios comunicados e informando a la gente, ¿no? Pero sí esperan que haya algo de impacto. Ojalá no tanto, pero mejor estar un poco preparados que nada, ¿no?
Sí, claro.
Ahí lo que se caiga, lo que se moje.
Sí, no, pues sí.
Ventanas, sí, aquí hacemos igual. Mejor.
Sí, no, más vale prepararse, pues si no pasa nada.
Exagerar un poquito.
Bueno. Sí, yo creo que sí.
Ahí uno arregla todo.
Ok, gracias.
Les aviso. Que estén
Ándale,
bien.
si sabes algo, pues ahí nos va. Ándale.
Suerte a todos.
Ándale.
Suerte a todos.
Suerte a todos, nos vemos la próxima semana.
Hasta luego. Gracias, Alina. Enrique.
¿Qué tal? ¿Cómo estás?
Que vaya a ti bien todo por allá.
The broadcast of Facebook Live has stopped.
Hasta luego.
Adiós.